Hello guys, so today we are here to solve the kth largest element in an array. In this problem, as is being shown here, we are given an integer array nums and an integer k. So we are given this integer array nums and the integer k. Given an integer array nums and an integer k, return the kth largest element in the array. So we are given this array and we are asked to give the kth largest element in this array. So if you take up the example, you see 3, 2, 1, 5, 6, 4. So if we order them, then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's just the natural numbers, but given in a random order. So in this, the second largest element, so largest element is 6, but the second largest element is 5. 1, 2, 3, 4, 5, 6. So the second largest element is 5 because the largest is 6 and the second largest is 5. So the output is 5. Okay. Now again, it's I guess 3, 2, 3. So it's 1, 2, 3, 1, 2, 2, 3, 3, 4, 5, 5, 6. This is that number, and so if we order these numbers, then it is 1, 2, 2, 3, 3, 4, 5, 5, 6. And we are asked to give the fourth largest element. So this is the same, same numbers. So the largest is 6, second largest is 5, third largest is 3, no 4, and then okay. So see here, 6 is the largest, but two 5s are there. So second largest and third largest both are 5. Then fourth largest is 4. Okay. And the output is 4. So we are, even if there is a repetition, we are accounting for it. Okay. So given this, how are we going to solve this problem? So, this problem, is giving us an idea that, you can use priority queue for this. And how are we going to use the priority queue? So we will use this priority queue. PQ is equal to new priority queue. So this is the way to initialize this min priority queue. This is not the max priority queue. If it is a max priority queue, then would have passed one, passed one comparator here. Okay. Int I1 integer I2 like that, and then would have used some lambda function. But right now we are not doing it. We are using this min priority queue. By default, when we instantiate the priority queue, then we are returned a min priority queue, and we will be using this. Now, what we will do that we'll pass these elements int I of nums in this priority queue, pq.add I, and at every iteration we'll keep on checking what is the size of this priority queue. If it is greater than greater than equal to k, so we should do greater than k. Okay, then we will be doing pq.poll. So what this poll will do, poll will take the element at the top and pull it out from that priority queue. So see, remember what I said, that at the line number 4, we are initializing a min priority queue. This is a min priority queue. This is not a max priority queue. Okay. So this is a min priority queue. Okay. So if this is a min priority queue, then what we'll be doing, we'll keep on checking at every iteration whether the size is exceeding k. If it is exceeding k, then we'll be using pq.poll. Okay. And then at the end, what we'll be doing, we'll be returning pq.poll. That's it. Okay. So we'll poll the element at the min, and then we'll be returning that. So let's see what is the output in this. Okay. So let's run this. PQ dot poll. Okay, it's cannot be converted to end dot value. Okay, not find symbol object. Oh my goodness. So can be an object. Okay, perfect. But without it also we should be able to, you know, get it. So we are using int value. Okay. Without this, oh my goodness, oh my goodness. We should be using this integer, correct? Perfect. So now when we are using this integer, then automatically that integer is converted into int and it is being returned. Okay, okay. So you remember we have used the difference between earlier and the new situation is that we have used in the angle brackets the integer thing. That's why this priority queue will only contain the ramp type integer, and we are returning pq.poll. Then that ramp type integer is being returned, but the required type is int, and that is getting automatically auto unboxed, and we are getting the int value out of it. So this is the way this solution is working. I would like to say some more thing about this, but let me first submit this. Perfect. So see, this solution is getting accepted. And I would like to say something about this solution. In this solution, in between these for loops, as you know, a loop, usually has an invariant. And in this problem, the loop invariant is that at any given time, the size of the priority queue can never be more than k. So when we are adding something, this operation is taking log of, let's say, k. And then this poll is also taking log of k. So 2 times this log of k, at most it is getting happening at most it's happening 2 times. So big O of log of k and 2 times. Okay, so as you know, the 2 times big O of log of k is similar to big O of log of k. So big O of log of k is the worst time complexity of this, because at most either we are adding it to the priority queue or we are removing it from the priority queue. Okay, and then at the end we are returning the minimum. So what's happening? Okay, what's happening that we are adding the elements in the priority queue, and as soon as we add the element, the internal characteristic of priority queue is that it contains the element in a structured way, and to maintain that structure it keeps the min at the root, and to keep the min at the root, a lot of restructuring internally happens in a priority queue. So for that reason, this add is, it's not just, appending the element to the back of the structure. Internally, a lot of restructuring is happening as soon as we add any element. Okay, and as soon as we remove an element from the root, then also a lot of internal restructuring happens. Okay, and because of that, this priority queue is taking log of k operation. Okay, log of k, the time complexity of this add and pull is log of k. And the worst, what can happen, that this add and pull, it can happen at most 2 times. It cannot happen, the best case scenario is that k is very large and we are just we are adding the element, and then we never need to do the pull. Okay, but the worst case thing can happen that we are adding also and then we are doing the polling also. So this 13th line, I meant to say, the worst case is happening when both the add and poll are happening within the single iteration. And that's why it's 2 times big of log k. And 2 times big of log k is just as big of log k, because the constant doesn't matter, okay, in big O notation. And at the end, we are returning the minimum element at the, since it is equally, so one more thing I would like to say, that we are adding the elements, and then as soon as it is k greater than k, we are pulling the element. So we are pulling out the minimum element from the priority queue. So at the end of the loop, what is remaining in this priority queue is that all the k largest element of the input array. So at the end, we are just pulling out the minimum element by doing pq.pull, and the minimum element is getting pulled out of that priority queue, and that is being returned. So this is the way this priority queue is functioning. Okay, so we are now very clear, what is happening internally in this process, in this solution. But you see that this time complexity is not very good. It's just beating 38.70 operations. Can we do something better than that? So if you look at that problem constraints, the range of elements is just very limited, minus 10,000, 10,000 to plus 20, plus 10,000. So in total, there are only 20,001 elements. So we can use this fact. Okay, what we can do, let me show you. Again, we'll create this. Okay. In this, what we'll do, that we will create one int array is equal to new int array. Okay, 20,000. Okay, 20,001. Let's do 20,001, because minus 10,000, then 0, then plus 10,000. So 20,001 is the total space requirement. Okay, and then what we'll do, that we will, for int I, nums I plus 10,000. So we are incrementing that I into by 10,000, so that if something is negative, okay, it can at most be from -1 to minus 10,000. So we are adding, so it's we are normalizing the things in a sense. Okay, and after doing this, we can, we can let's say we can increment it. Okay, and now we'll take one count, and count is equal to 0 for int I is equal to l dot length -1, I is greater than 0, minus I. Okay, okay, if so, now again we'll check if count is greater than, no, not here, not here. First of all, we'll count plus equal to R of I. Okay, and then if count is greater than equal to K, will be, breaking up. Break. So need not create this thing. We can just make it here in this line itself. Break. And then afterwards, what we can do, that we can do one return. Return of return of return of I. So we should, we should declare this I outside. Okay. Return I plus I minus. Already we have done 10,000 plus. Okay. And then what we are doing, we need to close this, and we need to close this as well. We closed it or not. Okay. So what we are doing here, that we are exploiting this fact that, the total numbers, the total numbers can be between minus 10 to the power 4 to 10 to the power 4. So we have initialized one array of 20,001 because this range includes 0. So we need to account for that as well. And then with, the negative numbers can be, the largest negative number can be minus 10,000. So minus 10,000 to, normalize that, because we want them to be put in an array of 1 to 20,000. So we are adding, the largest negative number can be minus 10,000. So we are adding plus 10,000 to each value, so that, if it is minus 10,000 is there, then it will become 0. And then we are initializing this count value, and then from the backside, I want to say, from the last end of the array, we are just incrementing this count with the, counts at each and every location, because the array, this array ARR is now holding the count of each and every value. And at the end, when we have to return this value, we are just subtracting 10,000 from the I and then returning it back. So I hope this should work. Let's run this. Perfect. Perfect. So see here, it's beating 10,000. It's beating all, it's beating all solutions. But the memory uses is very high. You see, earlier, the priority queue also, because in the priority queue, we needed to store all the elements. But actually, if you see, the memory uses is small, and that is very surprising, Maybe the priority queue is really heavy data structure. So it's better to use this, this counting sort logic. So this logic is basically counting sort. We are counting the elements at each and every index, and then we are, putting it over there. So with this, I hope, things are clear to each and every, all of us. So if you have any doubt, please post it in the comments, and I'll happily answer those doubts. So thanks a lot. Thanks for your support. And if you have any other doubt also in this solution, with any other solution of this problem, please let me know. Please put it in the comments, and I'll definitely try to answer them. With this, thanks a lot. Best wishes. Happy coding.